Galvanometer to ammeter. Here, galvanometer means it is an instrument to measure the current. Very small currents measuring instrument is called as galvanometer. And if you connect a small resistance in parallel to galvanometer, the small resistance I am calling it as S. So here capital G, first of all, let us see the terms here. Capital G is called galvanometer resistance, and S is called shunt resistance. Generally, shunt resistance means small resistance. Shunt resistance nothing but small resistance connected in parallel to galvanometer. So parallel connected resistance as a small value is there, that is the shunt resistance. Here capital G is galvanometer resistance, S is shunt resistance. So now they are connected in parallel. Then they are calling it as ammeter. The question arises, what is this ammeter? What is this ammeter? Just now I told that galvanometer is an instrument to measure small currents. Ammeter in a little big value of currents. So here ammeter we are measuring the current here also, but galvanometer for small currents, general currents with ammeter. Now this galvanometer is connected with a small resistance in parallel, so that what will happen beta? Effective resistance will decrease. Effective resistance will decrease means what will happen? We can allow more current through that one. That is the purpose. We call it is conversion of galvanometer to ammeter. Galvanometer to ammeter means galvanometer instrument to measure small currents, and total now this is called as ammeter. How it became ammeter means by connecting a small resistance in parallel to the galvanometer. If you connect like that, the effective resistance will decrease. Effective resistance will decrease means we can allow the more current to flow through this ammeter. So here the current which is coming here, let me call it as the current as I. I is the current coming through here. Generally now, these are in parallel combination. Parallel combination means current will divide as Ig and Is. So this Is is the current flowing in the shunt. That is the reason we named it as Is shunt current. And Ig is the galvanometer current. So Ig and Is, here if you observe carefully here, I divided as Ig and Is. Is and Ig they combined as I, and they'll come out from that ammeter. Now I is ammeter current. I is ammeter current. The total part is called as ammeter. This total one is called as ammeter. This is only galvanometer, and galvanometer will have some resistance, that is capital G. If we are connecting small resistance in parallel to the galvanometer, that's called shunt resistance. So that by connecting like that, any parallel combination of resistances will decrease the effective resistance. So effective resistance of this one decreased, that is ammeter resistance. Ammeter resistance has been decreased. Suppose the question is asked, what is the ammeter resistance? Ammeter resistance. Ammeter resistance is how these two resistances are there beta. These two are in parallel, G and S. So the total resistance parallel combination I can write G into S by G plus S. In current electricity chapter, we got this information how to calculate the parallel combination of resistances. Parallel combination of resistance means R effective equal to, suppose R1 R2, R1 R2 by R1 plus R2. So G into S by G plus S. This is ammeter resistance. Here RA is called what beta? RA is called as ammeter resistance. RA is called ammeter resistance. So ammeter is also measures current, galvanometer also measures current. Difference is ammeter will allow more amount of current, more strength of current, and galvanometer less strength of current. So like that we can differentiate between galvanometer and ammeter. Now we are converting galvanometer to ammeter. That is our target. Now coming to this topic here. So we connected in parallel, we told. We know that whenever in parallel combination, potential across the galvanometer will be equal to potential across the set. So parallel combination indicates potential difference are indicate, because in parallel combination, they are in parallel combination, so potential difference will remain same. So what is Vg beta? Yes, potential difference across galvanometer. Galvanometer. And what is Vs? Vs is nothing but potential difference across shunt resistance. Shunt resistance means small resistance connected parallel to galvanometer. So like that we can give the information. Now I can write Vg as Ig into G and Vs as Is into S. I can write like that. So Vg is Ig into G I can write, and Vs as Is into S I can write. So Ig into G is nothing but Vg. So galvanometer voltage is galvanometer current into galvanometer resistance. And voltage across shunt is shunt current into shunt resistance. Like that I can write. I hope you are clear with this idea beta. How I have given this information. I think you are clear. The potential difference across galvanometer, potential difference across shunt. Fine. One more beautiful point we can observe from the diagram beta. From the diagram I observed that the current which is coming here, it divides as Ig and Is. From Kirchhoff first law, sum of the currents flowing towards the junction is equal to sum of the currents flowing away from the junction. So that I can also write one more equation here. If I call this as equation number 1, I can take the equation number 2 as I is equal to Ig plus Is. So the total current I, that is the ammeter current which is flowing through ammeter, is divided for galvanometer and shunt. And so this is a equation number 2. Is is shunt current, Ig is galvanometer current, I we can call it as ammeter current. So this is the given information here. Now from these two equations, from equation 1 and 2, we have to solve further. So from equation 1 and 2, what we can write better? First of all, I is equal to Ig plus Is is the equation 1. From here I can write, I want to eliminate Is, so I can write Is is equal to I minus Ig. So in equation 2, what we have? Vg into what we have? Vg is nothing but what I wrote bit already. Ig into G is equal to Is into S. So this Is I am substituting here. So if I substitute like that, what will happen? Ig into G is equal to I minus Ig into S. So from this expression I can write S is equal to Ig into G by I minus Ig. This is the expression what I got. I eliminated Is. Nothing I did here. Just to carefully observe. Here Is I have taken as I minus Ig. Actually, we got this expression my previous page. If you observe, that is here Ig into G equal to Is into S. What I did here, I just eliminated this Is value by taking this Is from the equation number 2. I hope you are clear with what I did. Now coming back to here. So from equation 1 and 2, I equal to Ig plus Is equal to I minus Ig into G equal to Is into S. Fine. I hope you are clear with this one. Now this expression, I want to make it further simplified. So let me take a fresh page here. S is equal to Ig into G by I minus Ig. Suppose if I bring the Ig to denominator, this Ig I am bringing to denominator. How to write Ig bringing to denominator means, yes, S is equal to G by I minus Ig by Ig. So further we can simplify, simply we can write this one instead of this one. Direct step I am writing, that is I by Ig minus 1. So this is my final expression. S is equal to G by I by Ig minus 1. I hope you are clear How we got this expression? So now this is the shunt resistance. S is called as shunt resistance value. We got in terms of what? Capital G. What is capital G beta? Capital G galvanometer resistance. I ammeter current. IG galvanometer current. Like that we discuss these things. Now let us take a fresh page here. S is equal to G by I by IG minus 1 I wrote. Fine. Here I can also write Ig is equal to 1 by nth of total current. If at all, if Ig, if I am writing better, if suppose galvanometer current is written as 1 by nth of total current. Because we can write the because I is the, suppose if you take I and I is equal to Ig plus Is. Ig is the part of I. Ig is the part of I. So that part, if I have written Ig is equal to 1 by nth of I, Ig is equal to 1 by nth of I, then from here what should I write beta? Easily I can understand I by Ig is equal to n. So substituting this one in the above formula, I can write S is equal to what should I write? G by n minus 1. S is equal to G by n minus 1. That I by Ig I am writing it as n. I hope you are clear. So for objective point of view, this information is very important. So what is the things we discussed beta? First we started our journey with here galvanometer. We connected a small resistance parallel to the galvanometer. Galvanometer is an instrument to measure small current. For that, if you connect a small resistance parallel to that, then those two are in parallel. Parallel means effective resistance is G into S by G plus S. So if you connect like that, it is called as ammeter, we told. So this is also called ammeter resistance. Ammeter measures large currents, galvanometer measures small currents, like that we can say. So here ammeter is measuring current is I and galvanometer Ig and shunt as Is from the diagram. So after this, what we did beta, here we have taken the two equations as the galvanometer and shunt. Galvanometer and shunt both are parallel, we can write like this from parallel combination. Ig into G equal to Is into S, and again we also have I equal to Ig plus Is. From those two expressions, finally I got the Ig value, S value. I got S value, shunt resistance value as G by I by Ig minus 1, or I can write S equal to G by N minus 1. Now here one more important note point is how to connect, how to connect, how to connect ammeter in external circuit, ammeter in external circuit. Remember, don't get confused for this point beta. Here they are asking how to connect ammeter, not carrying measurement, current carrying instrument. So to how to connect the ammeter in external circuit means we have to connect in series, in external circuit, external circuit. Like that I can write here. I hope you are clear with this one now. How to connect ammeter in external circuit means connect in series in external circuit, like that we can write. Yeah, some students are confused why I am mentioning this one repeatedly means here. Generally, what is shunt meter? That is a galvanometer to ammeter. We connect a shunt in parallel. Shunt means a small resistance connected in parallel. We connect in parallel. So you will be listening whenever galvanometer to ammeter repeatedly the term parallel. But finally, what we told here, we told this is here ammeter. Now, ammeter how to connect an external circuit means it is not parallel. Ammeter is a current carrying instrument. It has to be connected in what combination? Series combination to the external circuit. I hope you are clear with this one now. So you have to be alert in this one. You must not get confused. This is the concept related to galvanometer to ammeter. Mainly for objective point of view, if you observe, these two formulas are very, very important for objective point of view. So S is equal to G by I by Ig minus 1, this formula, and S equal to G by N minus 1 for objectives. So your main points are how to convert galvanometer to ammeter by connecting small resistance in parallel to the galvanometer, it will become ammeter. That is the main point. And next point is about the formulas. This is what we derived. And finally, how to connect ammeter in the combination means ammeter combination is in external circuit is series. And also we also check that ammeter resistance. Don't forget ammeter resistance also beta. It is G into S by G plus S. I hope you are clear with the galvanometer to ammeter topic. So this is the topic very important. Then galvanometer to ammeter means you have to be good with current electricity topic, current electricity, and you have to connect to this one.